This is one of the most famous unsolved problems in physics, the three-body problem. Using Newton's laws of motion and gravitation, we are able to accurately describe the motion and trajectories of the bodies in a two-body system. It is thanks to these simple solvable equations that we are able to accurately predict the future of a two-body system. But what happens when we introduce a third body? Let us take a theoretical three-body system composed of the Sun, the Altair, and Alpha Centauri A. We know that the Sun weighs 1.98 into 10 to the power 30 kilograms. The Altair weighs 3.56 into 10 to the power 30 kilograms, and Alpha Centauri A weighs roughly 2.88 into 10 to the power 30 kilograms. Taking the ratio of these masses with respect to the mass of Alpha Centauri A, we get 0.71 ratio 1.27 ratio 1. Putting these numbers on a simulator, we get something like this. We can see that the trajectories of the three bodies are highly chaotic and very unpredictable. In fact, even a small tweak in the initial conditions of the system can produce dramatic effects in the future of the system. In the 1890s, Sir Henri Poincare showed that the three-body systems are chaotic deterministic systems, and it is due to this property that there is no general analytical closed-form solution for predicting the exact path of three bodies due to gravity. This is the three-body problem. When we say that there is no general analytical closed-form solution for the three-body problem, we mean that there is no single equation into which we could plug in the values for the initial conditions and get the output for the final trajectories over time. Well, then how can we overcome the complexity of the three-body problem when dealing with real-world scenarios? One way would be to use numeric integration, wherein we divide the problem into many small time steps and then calculate the gravitational forces at each corresponding time step to get the bigger picture. This is done using highly powerful supercomputers. Physicists have also discovered stable solutions for specific cases, for example, the figure 8 solution. We also have the restricted three-body problem, where relative to the masses of the two primary bodies, the mass of the third body can be considered negligible, and so the forces that this body exerts on the other two bodies can be neglected, and the entire system can be solved using classical Newtonian mechanics. An example for this would be the Earth, Sun and Moon system, where the mass of the Moon is so small compared to the masses of the Earth and the Sun that it can be neglected in the whole system. We can also approximate a multi-body system as a series of two-body systems. For example, our very own solar system, where instead of considering the solar system as a whole, we can consider pairs of the planet and the Sun. In chasing the orbits of three bodies, we discover not answers but the poetry of unpredictability. Thank you and have a nice day.